Hello everyone. Now we will move on to section 2.3, that is fractional powers and implicit differentiation. So in the last class we have seen how to find derivative of a function if it is of the form x raised to n. Then we know that its derivative d by dx is nothing but n x raised to n minus 1. Now what happens if the power is a fraction? So suppose we have x raised to 1 by n and we have to find its derivative with respect to x. So the power rule, this is called the power rule. This power rule is valid even when the exponent is a fraction. So fraction means the numbers are of the form p by q, where p and q are integers and q not equal to 0. So numbers of this form are called rational numbers. So the power rule is also valid if the power is a rational number. So that we will prove it first. So we have d by dx of x raised to r, where r is a rational number. Rational number means it is of the form p by q, where p and q are integers. Where the denominator is not equal to 0, then it is called a rational number. So d by dx of x raised to r is r x raised to r minus 1. Okay, so we have applied the power rule to rational power also. Now first we will see how to prove this. So suppose we want to find the nth derivative of x. So let y equal to nth derivative of x, which can be written as x raised to 1 by n. Here n is a positive integer. Now y equal to x raised to 1 by n, it implies that x equal to y raised to n. Now differentiate both sides with respect to x. So LHS become d by dx of x equal to d by dx of y raised to n. Now we know d by dx of x is same as dx by dx, and we know this is equal to 1. Okay. And RHS is d by dx of y raised to n. So here we have to use the power rule. So derivative of y raised to n is n y raised to n minus 1 into derivative of y with respect to x, that is dy by dx. So from this we will find what is dy by dx. So dy by dx is 1 by n raised to y raised to n minus 1, which is equal to, this power can be taken in the numerator. So this become 1 by n y raised to minus of n minus 1. So it become 1 minus n. So it is equal to 1 by n. Now we will resubstitute for y. What is y? Y is x raised to 1 by n. So we have x raised to 1 by n whole raised to 1 minus n. So this is of the form x raised to a into whole raised to b, which is nothing but x raised to ab. So here we will get 1 by n x raised to 1 by n into 1 minus n. So 1 by, now if you simplify in the power, so we have 1 minus n by n. You split it, it is same as 1 by n minus 1. So we have, this is equal to 1 by n x raised to 1 by n minus 1. So we have shown that the power rule is also valid if we have if the exponent is a fraction. So we have shown that derivative of x raised to 1 by n is 1 by n raised to x raised to 1 by n minus 1. For example, suppose you take y equal to 10x raised to 1 by 8. So we can see the power is a fraction 1 by 8. So we can apply the same power rule. So dy by dx is 10 into, so here you have 1 by 8. So 1 by 8 into x raised to 1 by 8 minus 1. So 1 by 8 minus 1 is 1 minus 8, so we have minus 7 by 8. So we got this, if you simplify, you will get 5 by 4. So 5 by 4 x raised to minus 7 by 8. So we have seen that the power rule is valid if the power is a fraction. Also, if suppose y is equal to x raised to p by q, where p by q is a rational number, then also we can apply the same power rule to find its derivative. So what is dy by dx? Dy by dx is d by dx of, now first we will prove this. So x raised to p by q can be written as x raised to 1 by q whole raised to p. Now this is of the form, now we know p is an integer, so we can apply the power rule here. So derivative of this term becomes p into x raised to 1 by q whole raised to p minus 1 into derivative of this term, that is derivative of x raised to 1 by q. So if we simplify here we will get p x raised to p minus 1 by q. Now derivative of x raised to 1 by q, so this will be 1 by q x raised to 1 by q minus 1. Okay, derivative of a fraction, we can use power rule that we have proved here. Okay, so using this we will get this. Now if you simplify, this is p by q. Now x raised to a into x raised to b is nothing but x raised to a plus b. So if you apply here, you will get x raised to p minus 1 by q plus 1 minus q by q. And it is 1 get cancelled, so it is p minus q by q. So we have p by q x raised to p by q minus 1. So it means that the power rule is valid. That is derivative of x raised to p by q is nothing but p by q x raised to p by q minus 1. For example, you consider this problem. Suppose we want to find derivative of x raised to 3 by 5. It is given, so we have to find dy by dx. So dy by dx of x raised to 3 by 5 is, we will apply here power rule, so we'll get 3 by 5 into x raised to 3 by 5 minus 1. So 3 by 5 minus 1 is 3 minus, so it is minus 2 by 5. So you will get 3 by 5 x raised to minus 2 by 5. Now suppose y is given as x square into x raised to 1 by 3 plus x raised to 4 by 3. We have to find dy by dx. So first we will combine the power of x and find the derivative. So we simplify this, we will open the bracket. So y is x raised to, so you have x square into x raised to 1 by 3, which is nothing but x raised to 2 plus 1 by 3. Okay, so it is x raised to 7 by 3 plus similarly x raised to 2 plus 4 by 3, so it is x raised to 10 by 3. Now we can find its derivative directly. So dy by dx is d by dx of x raised to 7 by 3 plus x raised to 10 by 3. So this becomes 7 by 3 x raised to 7 by 3 minus 1 plus 10 by 3 x raised to 10 by 3 minus 1. So it is 7 by 3 x raised to 4 by 3 plus 10 by 3 x raised to 7 by 3. So in this way we can find the derivative of composite terms also. Now we will apply, we will see the rational power of a function rule. So again we can apply the power rule here. So we have a function d by, we have to find the derivative of f of x, and we have whole raised to r, where r is a rational number. So again we can use the same rule. So it is r into f of x whole raised to r minus 1 into derivative of f of x. So it is derivative of f of x, it is f dash of x. So here r is a rational number. Okay, so we have d by dx of f of x. F of x may be any function in x whole raised to r. So again it is r into f of x whole raised to r minus 1 into we have d by dx of f of x. What is d by dx of f of x? It is denoted as f dash of x. So we have this rule. We can prove this using the chain rule. So we suppose let y equal to f of x whole raised to r. You put this function, this is a function of x, we can put it as u. So we have y equal to u raised to r. So u raised to r. So we can see that y is a function of u and u is a function of x. So we can apply chain rule. By chain rule we have dy by dx is dy by du into du by dx. What is dy by du? Dy by du means differentiate y with respect to u. So derivative of u raised to r. So it is r u raised to r minus 1. And then we have du by dx. What is du by dx? Du by dx is derivative of u with respect to x. U is f of x. So du by dx is f dash of x. So we have proved that dy by dx is r into f of x whole raised to r minus 1 f dash of x. Now we will see a problem. So we have y, let y equal to x raised to 5 plus 1 whole raised to 7 by 9. We have to find dy by dx. So here you have a function of x. Okay. So again we can use the power rule. So dy by dx is 7 by 9 x raised to 5 plus 1 whole raised to 7 by 9 minus 1 into d by dx of x raised to 5 plus 1. So this is 7 by 9 x raised to 5 plus 1, 7 by 9 minus 1, so it is minus 2 by 9, derivative of x raised to 5. So d by dx of x raised to 5 plus 1 is equal to derivative of x raised to 5 is 5x raised to 4 plus derivative of 1 is 0. So we have 5x raised to 4. So I have simplified this. So it is 35 by 9 x raised to 4 into x raised to 5 plus 1 whole raised to minus 2 by 9. So in this way we can find the derivative. Okay. Now see another problem. Let y equal to x by root of x square plus 2. Find dy by dx. Now for finding dy by dx we can use the product rule and quotient rule as such. Okay. So for example here it is of the form x by root of x square plus 2. So we have to use the quotient rule. So dy by dx will be root of x square plus 2 into derivative of x. Derivative of x is 1 minus x into derivative of d by dx of root of x square plus 2 whole divided by root of x square plus 2 whole square. So we have root of x square plus 2 whole square, which is nothing but x square plus 2. Okay. Now here we have to find d by dx of root of x square plus 2. So it will be root of d by dx of root of x square plus 2. So this is nothing but d by dx of x square plus 2 whole raised to 1 by 2. So if you find the derivative, we have 1 by 2 x square plus 2 x square plus 2 whole raised to 1 by 2 minus 1. Again we have to find the derivative into d by dx of x square plus 2. Okay. So here it will be minus x into half x square plus 2 whole raised to minus half. Derivative of x square plus 2 is 2x whole divided by x square plus 2. Now here you can take, you can see 2 will get cancelled. Now simplify it. So root of x square plus 2 minus x into x, you have x square plus 2 whole raised to minus half. Now x square plus 2 whole raised to minus half is 1 by root of x square plus 2. Here you can take LCM and simplify it. So this become x square plus 2 minus x square by root of x square plus 2. So if you simplify, x square will get cancelled. So it is 2 by x square plus 2 whole raised to 3 by 2. Here you have 1 by 2 and 1. So it becomes 3 by 2. So in this way we can find the derivative of functions. So one more problem is solved for you. So suppose y is equal to cube root of x into x square plus 2. Now again you can use the quotient rule. So it becomes x square plus 2 into derivative of cube root of x minus cube root of x into derivative of x square plus 2 whole divided by x square plus 2 whole square. So this becomes x square plus 2 into 1 by 3 x raised to 1 by 3 minus 1 minus cube root of x into 2x. Derivative of x square plus 2 is 2x divided by x square plus 2 whole square. Now we can simplify here. 1 by 3 minus 1, so it becomes minus 2 by 3. Here x raised to 1 by 3, x raised to 1. So you have cube root of x into x. So it is nothing but x raised to 1 by 3 plus 1. So it is x raised to 4 by 3. So I have written it here. Now if you open the bracket here and simplify it, you can see these two terms can be added. So you will get the simplified answer like this. Okay, so we will stop here. So in this class we have seen that the power rule for finding the derivative can be extended even if the power is a rational number. So in general, if we have to find d by dx of x raised to r, where r is a rational number, then you can apply the same rule, that is r into x raised to r minus 1 into r into x raised to r minus 1. Now you can apply this to if functions also. So if you have a function of x, you have to find the rth derivative. So this is nothing but r into f of x raised to r minus 1 into derivative of f of x. So it is f dash of x. So these are the two important results that we studied in this class. Okay, thank you.